NVIDIA just released an open AI model that can watch video, listen to audio, read documents, and reason about all of it simultaneously. And it costs 42 times less per token than GPT-4o. It's called Nemotron 3 Nano Omni. It replaces the duct-taped multi-model pipelines that most AI agents rely on today. I analyzed over 34 sources, including NVIDIA's technical report, Hugging Face model cards, and independent benchmark platforms to break down exactly how this model works, why the architecture is genuinely clever, and whether it actually lives up to NVIDIA's bold claims. Here's what we're covering. The real problem this solves, how 30 billion parameters only cost you 3 billion in compute, and the benchmarks that matter. No sponsorships, no affiliate deals, just the data. Let's get into it. Section 1. The problem. Most AI agent systems today are Frankenstein setups. One model reads text, another transcribes audio, a third interprets images, and a fourth handles the reasoning. Every single one of those is a separate inference call with its own latency and its own failure points. Every handoff between models means lost context. Imagine an audio narrator saying, "Look at this defect," while pointing at something on screen. A pipeline of separate models literally cannot connect those two signals. That context loss is a fundamental limitation. This fragmentation also compounds costs. You're paying for 3 or 4 models running in sequence, and errors cascade. Nemotron 3 Nano Omni's entire purpose is to collapse this mess into a single model that processes text, images, video, and audio in one unified inference call. No handoffs, no lost context. Section 2. The architecture. This is where the engineering gets clever. The model uses a hybrid mixture of experts design. Think of it as a company with 128 specialist employees, but for each task, only 6 of them show up to work. You get expert-level knowledge at a fraction of the compute cost. The backbone interleaves 3 types of layers. There are 23 Mamba selective state space layers, then 23 mixture of experts layers with 128 experts and top 6 routing. And finally, 6 grouped query attention layers for precise global reasoning when the model needs to look at everything at once. For vision, it uses the C-Radio version 4H encoder. For audio, it uses the Parakeet TDT 0.6 billion parameter encoder. The model was trained on nearly 355 million data items across 1,395 datasets. That training scale is staggering. The context window supports 256,000 tokens, which is double GPT-4o's limit. It can hold hours of multimodal content. Now here's the key innovation. The audio and visual tokens sit in the same context window and directly inform each other. Efficient video sampling reduces redundant video frames, cutting video reasoning compute by roughly 2.5 times. Cross-referencing NVIDIA's claims with independent platform documentation from Together AI, Crusoe, and Clarify, multiple sources confirm this efficiency advantage isn't just marketing. Section 3. Benchmarks and real performance. Does it actually deliver? NVIDIA's technical report states 9 times higher throughput than other open Omni models with the same level of interactivity. On the MediaPerf benchmark, it achieved the highest throughput and lowest inference cost for video-level tagging. It tops 6 major leaderboards spanning document intelligence, video understanding, and audio understanding. On OS World, it scored 47.4, a 76.58% improvement over its predecessor. It's dramatically better at navigating interfaces. Now, the cost comparison. Input tokens cost 6 cents per million on deep infra, compared to $2.50 for GPT-4o. That's 41.7 times cheaper. And because it's open weight, you can self-host it for effectively 0 marginal token cost. But let me be transparent about the limitations. This model only outputs text. It cannot generate audio or video. It understands them as inputs but responds exclusively in text. So, we're noting where claims are self-reported by NVIDIA versus independently verified. That's an important distinction, and I want to be upfront about it. Section 4. Who's actually using it? Real enterprise traction is already building. Foxconn is using it for visual inspection. Palantir is applying it to intelligence analysis. EcoCare is deploying it in healthcare. And companies like Dell Technologies, DocuSign, Infosys, and Oracle are actively evaluating it. What kinds of tasks are we talking about? Processing a 2-hour meeting recording, video, slides, and audio in one pass. parsing complex PDFs with embedded charts and tables for compliance workflows, building computer use agents that can see and navigate graphical interfaces. We checked the actual model card on Hugging Face, and the training data transparency is remarkable. 355 million items across nearly 1,400 datasets, all documented. It's fully open under the NVIDIA Open Model license with open weights, open synthetic training datasets, and open training recipes. You can run it locally on Ollama or Llama.cpp with around 25 gigabytes of RAM. That said, the NVIDIA Open Model license is not Apache 2.0, so if you're planning commercial deployment, read the terms carefully. Now, the bigger strategic picture. Why would NVIDIA give away best-in-class AI software for free? Because you need GPUs to run it. The Nemotron 3 family is a modular agent stack. Nano handles perception, Super handles planning, and Ultra handles reasoning. NVIDIA isn't just selling chips, they're building the operating system for AI agents. The family has seen over 50 million downloads. Conclusion: Nemotron 3 Nano Omni represents a genuine architectural shift, collapsing separate models into a single unified system. The numbers are compelling: 30 billion parameters with only 3 billion active per request, 9 times the throughput of comparable open models, 42 times cheaper than GPT-4o per token, and strong results across 6 major benchmarks. The open-weight strategy makes this accessible to individual developers and enterprises alike. Multiple sources confirm the advantages. Whether you're building AI agents, processing enterprise documents, or exploring multimodal reasoning, this model deserves serious attention. As always, this analysis is completely unsponsored. I have no relationship with NVIDIA, just thorough research and honest conclusions. If this breakdown helped you understanding Nemotron 3 Nano Omni, hit subscribe. I research AI innovations like this every week so you don't have to read 34 sources yourself. Drop a comment telling me, would you rather self-host an open model like this or stick with closed APIs like GPT-4o? I read every comment. And if you found this valuable, share it with someone building AI agents. They need to know about this model.